Yes, all. Am I audible to all of you? Yes, ma'am. All right. So, good evening, class. Let us continue and complete this chapter, heating effect of electric current we were doing. And there is one more topic, Kirchoff's law left. So, let us complete that. What all things we have discussed? We have discussed power. That power is the rate of change of energy. Energy upon time. Three formula there. VI, V square by R, right? And I square R. These three formula. Then we have started with the energy dissipation. So heat energy that is dissipated when the electrical appliances are connected, it is I square RT. Okay. So H is equal to I square RT, H is equal to V square by R into T, H is equal to V into I into T. Basically, you multiply power with time. So this was a small derivation about it, and that's all what we have studied in the last class. Let's come to the electric bulb. There are few questions about electric bulb in your syllabus. Electric bulb has just one basic thing that you need to understand. This is how you represent a bulb. If this symbol is given, this is how you represent it in terms of current electricity. And if the symbol is like this, it means the bulb is glowing. This means bulb is glowing. Okay, now see, when we're talking about this electric bulb, it is written. Usually, see, when the bulbs are manufactured from the company, there are certain ratings from it, which is known as power rating. So you'll often find such terms written on the bulb itself and in the questions that will be given to you, like 220 volt, 100 watt. Terms like this will be mentioned. So this means that this is known as power rating or rating of the bulb. Power rating. See what is the meaning of this. This means that at 220 volt, the power dissipated the power dissipated is 100 watt. Okay. So it means, and 100 watt means in 1 joule, in 1 second, 1 joule of energy is being produced. So at this voltage, this much of power will be given. This is what is meant by the rating. So you will not be given anything. You will be just given the two terms like this. So you have to know that this means that at this voltage, this is the power given. And remember, there are many questions that have come in the exam based on the power and the brightness. Means they will give you every data about it and they will ask you which of the following bulbs has the highest power or highest brightness or is glowing the most, like this. So that is no more a question of brightness or dullness. It's just a question of power. You know how you have to calculate power using this, the three formula that we have studied. Calculate the power using VI, V square by R, I square R. And which one has the least power will glow the least. Which one has the highest power will be the brightest of all. So those questions are there. So by remembering this, you can remember more the power, more the brightness. Lesser the power, lesser is the brightness. Questions come from this. But brightness is just related to power, so you calculate power. Let's practice a question. This says the electric power consumed by a 220 volt 100 watt bulb. Now see, this is what I was referring to. That electric power consumed by a 220 volt 100 watt bulb when operated at this and all. When this is given, this means it's the rating of the bulb. That is when the bulb was produced, what was the rating given, how it was constructed, at what voltage, what power will it give. So this is what is meant by it, the power rating of the bulb. So here voltage is given as 220 volt and the power is given as 100 watt. So it says you have to find the power when the voltage is 110 volt. So look, from here we can get the value of R. Resistance can be calculated. Look, P is equal to V square by R. So we can say R is equal to V square by P, because using this at least we'll get the value of R. And resistance will remain the same. Resistance of a material won't change. So we know, yes, resistance we can use for this. So resistance will be V square 220 into 220 divided by 100. So resistance will be 484 ohm. Okay, 0, 0, 0, 0. Yes, 22 whole square, 484. So we have the resistance now. So resistance is 484 ohm. Voltage is 110 volt. Now the new power is asked for this. So power will be V square by R. Let's say this was V1. This was P1. Okay, so P1, V1. And this is V2. P2 we have to find out. So that this is different and this is different. So we will get P2 will be V square 110 into 110 divided by 484. So try this. Tell me out of all the four options, which is one is the correct one, which is your answer. This has come in the board exams in the MCQ 1 mark question. So see, this much was there in just a single mark question. First write down this, then come to the question and tell me the answer that you are getting out of all the four options. We'll do one more question that has come in the board exam, and then we'll move on to the Kirchoff's law. Okay, please write it, class. I hope this is clear to everyone. Yeah? Yes, ma'am. All right.
Ma'am,
Yes, Subedullah.
why is it minus 220 volt minus 100 watt?
That's not minus. That's what I was saying. The power rating will be given like this, 220 and 100. This is not minus. This is just the power rating of the bulb. This is how the bulb's rating is given. Bulb's power rating. It's, you can take it like comma, as if 220 volt, 100 watt is given. That's not minus.
So instead, can we put comma?
Yeah, you can, but this is what the question gave. So in the questions, this can be given like this. While
So we
writing
can
in your
represent in
solution,
two
you
ways.
can. Yes, yes, you can. In your solution, you can write this. Yes, Ali, correct. Answer is 25 watt. First option. Let me know done.
Ma'am, ma'am,
Yeah, say.
the resistance will not change.
No, resistance will not change because see, here when you are talking about a bulb, if you remember from your lower classes, the components of a bulb, filament, which is made of tungsten and all, so the material of the device remains the same. So resistance doesn't change. That's why we have taken the same resistance and we have followed this formula. Whatever resistance is here at the manufactured level, it will be at every level because the material that is taken in the filament of the bulb, that will be the same only. Resistivity, resistance, all these things won't change.
If material is same, then resistance will also be same.
Yes, same material, no? Remember, we discussed
So,
that resistance depends on four things: length, area, Nature of material and temperature. So this is from the nature of material.
Yes.
Resistance, to change the resistance, we have resistors. We have been studying about these resistors. That's why the resistance was continuously changing. But right now it is about the bulb's inner segment, which is made of tungsten. So that the resistance of the tungsten will remain the same. Resistors were devices to change the resistance, because resistance is a property that is material dependent. When it is material dependent, it won't change. So to change the resistance, so as to get a preferred current, we require devices that were known as resistors, which we have studied. Resistors are there, rheostat is there in your school, in your labs. You must have seen the rheostats also, I think. So those are devices to change the resistance. Otherwise, if you have a wire, its resistivity is fixed. Okay. If this wasn't the case, then every time you would have switched on the bulb, it would have glowed differently. If the bulb is bright or low, that is because of, again, this power. Voltage is lesser, so lesser power, lesser brightness. Voltage is more. We use these terms. No, voltage is very low, a very dim light is there at the home. That is not due to resistance. It's due to the voltage which is supplied. Current voltage is affecting the power, which is affecting the brightness. None of them are related to the resistance. Okay?
Yes, ma'am.
Okay. Done?
Yes.
All right. Rest of you also? Let-
Yes, ma'am.
Okay, let's go further. Okay, last question from this part, then we'll be left with Kirchoff's. This says that two resistors, 4 ohm and 6 ohm, 4 ohm and 6 ohm are connected in parallel across a battery. So now we are talking about resistors. So different resistances will be there. R1 is 4 ohm, R2 is 6 ohm. Okay, and these are connected parallel across a battery. Okay, a battery is here. Let's say some V voltage is there. It says ratio of the power dissipated in them, P1 by P2. Look, class, this is voltage. Can you tell me, will the voltages for the individual resistors be different or same? Yes, Aisha, you answered something?
Different.
Different. Parallel connection.
Oh,
In
yeah,
parallel
same.
connection, voltage remains the same. Okay. It's a parallel connection. So the voltages across the resistors will be the same. Now look, voltage is same for both of it. If the supplied voltage is V, then the individual voltages will also be V. That's what we have studied in the individual circuits. I think once we practiced a circuit of 5 ohm and 10 ohm. Yes, in the parallel connection, the same thing, 5 ohm and 10. So see, let's take the ratios of it. Now, power is there, resistance is there, and voltage is there. Again, we are going to use the formula. P1 will be V square by R1. V is the same, R is there. So V square by R1. While P2 will be V square by R2. We have to find the ratio of P1 by P2. So P1 by P2 will be V square by R1 into R2 by V square. This gets cancelled. This is left with R2 by R1. So P1 by P2 is R2 by R1, 6 by 4, which is equal to 3 by 2. So the ratio is 3:2. B option. Okay, this is a question from 2020 paper. Is that clear to all? Got it?
Yes, ma'am.
Okay. Please write down this too. Completed?
Yes, ma'am.
Okay. Let's come to Kirchhoff's law. All right. So basically, we've studied about the different kinds of series and parallel combination. Now we'll study if series and parallel combinations also do not work, means what we have studied. Sometimes we aren't able to identify whether a particular case is in series or it's in parallel. It's very difficult to identify. So Kirchhoff's law is the best to solve any question. The advantage of Kirchhoff's law is whether the circuit is in series, parallel, is in combination of both, is in neither series nor parallel, you can apply Kirchhoff's law. But the disadvantage is that it's a very lengthy method. You require a lot of time to solve because the equations that form are very hectic to solve. So if you aren't able to solve a question using the simple series and parallel method, you can always go for this method. But if you are short of time, then don't attempt this question if it is optional. Means if you are lacking time, try to go for the other questions. Now, there are two laws here in Kirchhoff's law. First law is about the voltage. Okay, first law is about the current. This says that at a junction means when the wires are crossing each other, like the branching of a wire, which we say, that is the junction. So whatever current is entering will exactly be equal to the amount of current leaving the junction. Let's say this is a resistor here, this is another resistor, this is another resistor. So let's say some amount of current I1 has been here. This is I2. This is I3. And this is I4. This is how the current is traveling. So this is known as a junction, where the wires are crossing each other or where the wires are tied up. So we say the current entering, the current which is entering is equal to current exiting. So look here, I1 is entering and I3 is entering. So we can say I1 and I3 are entering, which is equal to I2 and I4, which are exiting. So I1 and I3 are entering and I2 and I2 and I4, they are exiting. So the entire equation will be I1 minus I2 plus I3 minus I4 is 0. That is what is the Kirchhoff's current law, which is known as KCL also. Means summation of all the current will eventually be 0. But every time this is not valid, you can get a remaining value. But when you equate with the RHS and LHS, they'll eventually get cancelled. So that's why we say summation of the current is 0. Current entering is current exiting. Questions have been asked where directly laws are asked. So you should know what's the law. And we'll be studying about how the applications of this, how to apply this. That is a little different to what we study because applications are a little tricky and lengthy. So that we'll do with the questions. First, understand gradually what are the laws and what are the rules to solve and apply the Kirchhoff's formula. When we'll come to the question directly, I'll start with a question only because there is no example that you can take. Directly, I'll start with the NCERT's question. So that will give you a good idea how to exactly apply. But first, have patience and try to understand a bit. But still, if any doubts are there, you can always stop. So here, Kirchhoff's second law is the loop law. Okay, loop law means in a closed loop where the wires are intersecting, a closed loop, the net voltage is 0. Sum of all the voltage is 0. This is KVL, Kirchhoff's voltage law. All right. So see how we follow the Kirchhoff's voltage law. There will be a loop chosen. Okay. There will be a loop chosen. So when the loop is chosen, we are going to set a direction in which we will be moving across the loop. Now, if we are moving from the negative terminal of the cell to the positive, we are going to write the voltage as plus 10 volt, plus 5 volt, plus 4 volt, whatever is given, plus EMF, plus E. If we are moving from the positive to the negative, higher to lower, negative. Okay, from the negative to higher, the positive, that is plus. Higher terminal to a lower terminal, it will be negative. We'll see what are these laws, how to apply. It might be a little confusing right now. I'll just start with the question. First, understand the basic laws. Then resistors will also be there. Cells are there. Apart from cells, the resistors will also be there. So how to manage these resistors? If we are moving along the direction of current, like the current is moving towards the right, and according to the direction that we have chosen, we are also moving towards the right, we'll take the voltage as negative. Now here in the cells, the voltage is directly EMF, so you just put a plus or a minus. Here, since the voltage is directly not given, it's given in terms of the resistance and the current. So you are going to use the Ohm's law here. That is V is equal to IR. Now, whether this IR will be a positive or a negative value depends upon the direction of the current. If you are moving along the direction of current, this is plus IR. If you are moving in the opposite direction, suppose I have chosen a direction, let's say clockwise. I'll be definitely moving like this. So here I'm moving along. So this one will be negative. Let's say I have chosen a direction again clockwise. So I am moving in the opposite direction to the current flowing through the wires. So I'll put it as positive IR. These are the basic rules which you should know. I'll start straight away with this question. First, tell me, till here, is there any doubts or have you understood anything? Okay, what about others? Aisha, Marwa, Ubaidullah, got it?
Yes, ma'am.
And what about you, Ubaidullah? You've understood?
Yes, ma'am.
Okay. Write it, all of you, then. Let's start. Then after words, I'll start with it. And we'll do the derivation of Wheatstone bridge using this only, Kirchoff's method. Please write it, class.
Ma'am,
Yes, say.
this is EMF.
Yes, yes, the EMF of the cell.
Ma'am,
Hmm.
which movement is this referring to? Like current or potential difference?
Which one?
In both the cases.
These arrows that I have drawn beneath,
Yes.
that is the direction that we will choose in a loop. We will go anti-clockwise or clockwise in a loop. So this is that. And these one are the ones applied by the cell. I'll show you in this question also that we'll do. Done.
Yes, ma'am.
Okay. Yeah, class. Let's discuss this. This is a question from your NCRT only. See, here we'll form various loops. Names are already given A, B, C, D. You can see this is one closed loop, this is one closed loop, this is one closed loop, right? Look, this one, this one, this one. Okay. So what you have to do, this question I'll be solving completely from the next question. You all tell me how to do that. First, we have to choose a loop in which we'll be solving the entire and making the equations. So how are the loops named? In loop, see, look at this loop. A, B, C, A. Okay, that's how it can be closed. A, B, C, A. You have to write the first letter back. Because if you just write A, B, C, that is just open two branches. Just A to B, B to C. You have to write back to C to A. So this is in loop A, B, C, A. All right. So we have chosen our loop. This is our loop in which we'll be applying the KCL and KVL. First, we need to apply KCL throughout because current enters, current leaves, and all, and current's distribution is important because if you have the current's distribution, then you can apply the KVL in every loop. Let us distribute the current. From the cells, the current will evolve, basically come out from the cell. Just take some value. Let's say from one more thing, remember, try to take the least number of variables as possible. Like if I say, let's say from this battery I1 current is coming, in this branch some amount of current went, in this branch some amount of current went. Let's say the value I2, some amount of current I2 went in this branch. Okay, so instead of taking I3 here, I1 was coming, I2 has gone. So what is left which is coming in this branch? I1 minus I2. This way I have a lesser number of variables because in any ways I have to take one more current that will automatically make it I3. So when this is I3, let's say this in this branch the current is I3. And in one branch you will have just one current. Obviously two currents will not be flowing. So in this branch, let's say I3 is going. So I1 minus I2 is here. Okay, I1 was coming, I2 went off there. So I1 minus 2, I1 minus I2 is coming over here. Okay, look, I2 is coming from this side and I2 is coming from here, I3 is coming from here. So when you have both the currents here, I2 and I3, I2 from this side, I3 from this side, they'll get added up in this branch. So this will be I2 plus I3. Okay, this will be I2 plus I3. Now see, we've already taken from the starting that I1 was the current in this branch, right? Because the cell supplied I1. So in this entire branch, the current will remain I1 only, like I3 remained here. So this will be I1 only. Because in one single branch, you cannot have variable currents. One single value because these are constant, so your current will also be a constant. Now I2 and I3 were coming here, I1 has left. So you are left with I2 plus I3 minus I1. And from here, what was coming? I1 minus I2 was coming. So it clubbed together. Look, are we getting I3 back or not? Because if we aren't, then it means we have done some mistakes. Every current should be evenly distributed. Yes, I2 will get cancelled, I1 will be cancelled, only I3 will be left. When these two get added, we'll get I3. It means the distribution that we have done is right. Now, coming to your queries, which must be coming up in the mind, that how do you know you have to take I3 only in this branch or I1 only here? That's not a rule, class. Suppose I am solving this question with this method, randomly I distributed the current and I felt I'll be able to solve it through this. Because we'll be needing, and three loops are there, so three equations will be formed, so I'll be able to get the rest of the things. Let's say Aisha is solving the question, and Aisha took I1 coming here, and she took that instead I'll write with the red one. So see what Aisha wrote. Let's say I1 was coming and she said, okay, I2 went here. So here in this branch, I1 minus I2 will go. Now, is it reversing your answer? No. See, if my value of I1 minus, let's say I1, I solved the entire circuit, how to be solved, and I'm getting I1 as 3 ampere. Okay. Aisha will also get 3 ampere because this branch we have taken the same. I am getting I1 minus I2 as, let's say, 2 ampere. Aisha took I2 only in this branch. She didn't take I1 minus I2. Her I2 will be 2 ampere. My I1 minus I2 will be 2 ampere and her I2 will be 2 ampere. Are you getting it? It means one branch will have the same value of current. Your final value of current in that particular branch should match. Nobody is going to check your variables. You are independent to write the variables, write the direction. Naming of the loop is fixed, but naming of the variables can be anything. If I wanted, suppose I didn't see this battery initially. Let's say Marva was solving this question. So instead, I'll just remove this one. Let's say if Marva was solving this question and she started from here, she took this as I1. If this was I1, she took something else here. Let's say she has taken this as I1. When I solve this question, let's say I am getting current as 5 ampere. So when Marva has solved this, she will get I1 as 5 ampere. So your teacher will cross check in this branch, you getting 5 amperes or not, whatever you've chosen, I1 minus I2 plus I3, whatever is it. In one single branch, one single value of current will come, because that's how it is possible. Physically, it's not possible that two kinds of currents are there in a single wire when the resistance and voltages are fixed, because here the values are fixed. So one branch will have a single amount of current. So you are independent. You can distribute the current evenly, but you should know one thing: take the least number of variables. Like now, I1, I2, and I3 are there. Three equations can be formed here. But if I had taken this as I3, this as I4, there will be more variables and it could be minimized. So try to have the least number of variables possible. So remember, in the branches, you are independent to write. Second of all, how to check whether you're doing it correctly or not. See, in every branch, all the things will come evenly and distributed. Finally, you'll get everything distributed. Like, see, I just randomly started from here, I1. I said I2 went here. So now I1 minus I2 is left. This I did. And I said from this, let's say I3 was coming. Now I cannot, what do I do about this one? So I took that, okay, I2 and I3 will be added and they'll be giving I2 plus I3 in this branch. Then I1 went off. Why did I1 go off? Because initially I had taken I1 was in there in this branch. So I2 plus I3, I1 had already gone earlier. So I2 plus I3 minus I1 was left. From here, initially I had already taken that I1 minus I2 would come. I2 plus I3 minus I1 combined with I1 minus I2 is giving I3 back. Suppose in this one, when I solved, I was getting a plus I1 here. Okay, let's say this is plus I1 plus I1. What will I get here? I2 will be cancelled. I1 plus I1. I will get 2I1 plus I3, which is not matching with this because here I have taken that the supplied current is I3. So immediately that gives me a hint that I have done some mistakes here and there, which is this negative sign. So here this will be minus, so that you get I3 back. This is how you have to check. Now tell me, class, this much of content is clear or not? Distribution of current part, applying
Yeah.
KCL. Yes, say.
Why are we writing I1 minus I2?
Because I1 is supplied from the cell. It's a branching. It's like if I draw it like this. I1 is coming. I2 went to this branch. How much will go here? From I1, you're subtracting I2. Let's say 5 amperes of current are coming from I1. Okay, 2 ampere went here. So how much will be gone here? 3 ampere. How did you calculate? 5 minus 2, that is 3. I1 minus I2. So the same whole parallel part, the way we have studied the parallel branching, is this only. It's just the shape is given like this. Okay,
How are we doing I2 plus I3 minus I1?
because we initially took that I1 is in this branch. Okay, I1 went from this cell. This I started with. It means in this whole branch, I1 will be there. And what's the direction of I1? Towards, pointing towards A, from C to A, because that's what I've taken initially. I cannot make that in one single branch. If this is the branch, current is coming from here and the same current is going from here. This is not possible. So one thing is sure, that current is also moving like this. So a certain amount of current was coming. Let's say 10 ampere is coming. And this had initially 3 ampere. This had, it means this is also 3 ampere in this part of the branch. So what will be left? 7 ampere will be left. Now come to the variables. This 10 ampere is represented by I2 plus I3 because they were coming. In this branch already I1 was existing, which was going away. Like 3 ampere has moved away. Look it in terms of the variables like this. 10 ampere was coming, 3 ampere is moving away. So we already assume that this will be 7 ampere. So I1 has gone. So 3 ampere is representing I1, 10 ampere is representing I2 plus I3. So how much is left? I2 plus I3 minus I1. Got it? Now,
How do you know that there is I1 and I2 plus I3?
how we know that?
There is I1 and I2 plus I3.
There is I1 and I2 plus I3?
Yes, ma'am. Because from that we are subtracting I1.
Look, you see the direction of current. That's what I was saying. Initially, I had taken this as I1. Initially, when I was marking in this particular figure. Okay, in this case, I'll show you the other questions also where I'll take a different direction. Right now, because the current is set, so I'm not erasing and explaining. Just get this through this example only. I1, I took it coming out of the cell. So isn't it obvious that the current will be pointing towards the left side only on this side of the cell, of the side of the branch also? Yes.
Yes.
Now see, here the direction of current when I2 is coming, I3 is coming. So now it's not possible. See, if the direction of current was like this, I3, just for a second. I2 was coming, some amount of current, I3 has gone. So I would have written I2 minus I3. We see everything with respect to the direction of current. So since the current was coming from here, I added it because obviously current is coming from this side, coming from this side, so it will be added. The sum will go here through this wire. If it was the opposite side, I would have taken minus. So direction is very important. Now it has moved till here. At this point, C, when I1 is moving towards A, the direction shows us that some amount of current has left. If this was the case, let's say initially this was the direction of movement, then here at this particular point, I would have taken I2 plus I3 plus I1 because I1 is coming to here, to this junction like this. Both the currents are coming, they'll get combined and come here. But that's not the case. What do we have right now? This I1 is towards A, this I1 is towards this. So obviously current has gone, so current has to be subtracted from this. Now got it? This is not something that we are taking, that why the current has gone here or we have chosen from ourselves that, okay, let's say the current is going towards right. Now, initially I had chosen this. Now in the same branch, you cannot have two values of current, two different values of direction. So if the current is going away, it means some amount of current from coming one has gone away. Like this, if this direction was this, let's say the battery was reverse and I had taken the direction like this. I2 was coming, I3 had gone in the wire, I would have written I2 minus I3. Then the equations would be different. So you see it according to the direction of current. Now, is that clear, Ubaidullah?
Yes, ma'am.
Okay. Anyone else? Anything? Ali, Aisha, Marwa?
How is it I1 minus I2?
I1 minus I2 in the sense, I have assumed that I1 amount of current is coming. In this branch, it's like if I just modify a little for you, look, this is the cell 10 volt. From this, two branches are made. This is the point A. Look here, two branches are made. One branch is moving here, one branch is moving here. This is how I'm showing. This is how the direction it is inclined towards the right. I have moved it towards the left, same branch. Now you'll be able to understand. I am assuming I1 is coming. In one of the branches, some other current will go, some amount of current will move away. That's what we have studied. Branching affects current and charges. So when a branch junction is created, so the current, some amount of current will get split up. Now, evenly, unevenly, that we will see later what's the value of current coming. And that's what we've been doing in the parallel combination also. So let's say I2 is the amount of current that has gone into the other branch. So what is left with us in this branch? I2, I1 was coming, I2 has gone in one of the branches. So we'll get I1 minus I2. Like this, take some value and get yourself understood. Let's say I1 is 10 ampere. 2 ampere went here. So we'll automatically say 8 ampere will be left. So what is this 8 ampere? 10 minus 2, I1 minus I2. Same thing, instead of this, the figure is made like this. One branch like this, one branch like this. But it's the same thing. It's all about the concept of the branches getting divided. So current eventually gets divided. Now you've understood, Aisha?
Yes, ma'am.
Okay. So this is how you have to distribute the current. The next question is a little simpler one. So you'll not have so much trouble in it. And this is a good question from your NCRT. So practice this properly after the class as well. Now, this is how you distribute the current. So what was the loop that we took? A, B, C, D. And I told you that we take a direction, clockwise, anti-clockwise, it's up to you. You can take any direction. I'm telling you, at the end, the value of the current in the branch will be the same. That is the ultimate task, because fixing variables and making it standard is difficult. So you can choose any variables from your side. Let's say we are moving clockwise. Okay. Now let's follow the rules, what we have studied, and let's apply it here. So from A to B, see how clockwise. A to B to C to A. This is clockwise. If it was anti-clockwise, I would have gone A to C to B to A like this. But since it is clockwise, I'm moving A to B to C. This is my direction. Now let's see. We have a resistor and a current. We have to write the net voltage of the loop. We are now applying KVL. KCL has already been applied. Now we are applying KVL. That's the second part of the Kirchoff's law. So here the current provided is I2 with the resistance along 4 ohm. So what's the voltage? We are going to use V is equal to IR wherever the resistor is present. So C class, what did we study? Voltage will be current into resistance. That is 4I2. This is the voltage. If I had given you this question as a separate part under the category of the series and parallel, you would have written this as the net voltage. So 4 into I2. So I've also written this. This is the voltage across this wire. Now, coming to the sign convention that we have studied, we moved along the direction of current. Current is moving from A to B. We are also going uphill, A to B. So we are going to put a negative sign. Look in the rules that you have written just before this. We have studied this only, that negative sign along the direction and positive sign if you're going away. So from A to B, we are going to put minus 4I2. Now, how are we going about the loop? We're going in a clockwise manner. So A to B, now coming down B to C. What's the current? We've chosen earlier, that is the sum of I2 and I3, I2 plus I3. Resistance is 2. So the voltage will be 2 into I2 plus I3. Now we moved down B to C. How is the current moving? Already the mentioned current is moving from B to C. That's why applying KCL is important. Then you have KVL. So we are moving along the direction of current. That will be negative. So we are going to put a negative sign. Minus 2I2 plus I3. All right. Let's go towards the last
Huh?
part. Yeah, say
How do you know that it is in direction of current?
clockwise and anti-clockwise. See, this red mark, can you see this red arrow?
Yes, ma'am.
This is a direction that you have to choose. When you mark the loop, there is a direction that you will be choosing. Okay, Ubaidullah, like clockwise or anti-clockwise, depending on your wish, that won't affect the final answer. It's not a standardized protocol to choose anti-clockwise always or a clockwise. You can choose any. In the next one, I'll choose it anti-clockwise. Anything like this. Okay. So you choose a particular direction. Now you start moving according to the direction you have chosen. Okay. Clockwise means A to B, B to C, C to A. This is clockwise. Do you agree?
Yes.
Okay. Now, current direction we've already stated in KCL. So we will match the direction of current and the direction that we have chosen, clockwise or anti-clockwise. So current is moving from A to B in this, and we have chosen clockwise. That is again from A to B like this. So we are moving along the direction of current. So negative. Now got it?
In KCL, how we manage to write these directions for current?
That we wrote before this. That was what we were discussing.
We did from
So
positive to negative, right?
we did from
Positive to negative.
positive to negative. No,
Yes,
no. See, if you go by that way, you'll be never able to write. See, once the current is, remember this. If I say this is a resistor, I'll never be able to predict the direction of current if the resistance is given at first. Because current and resistance have no relation with direction. It's the cell which supplies the current. Right? Cell is the one which supplies the charges and the charges move, which is in the form of a current that comes out. So resistance is there that won't give us the direction of current. Perhaps if you have the direction of current mentioned, you can find out the signs of the resistance. Current flows from a higher potential to a lower. So this will be positive, this will be negative. Maximum, this could be derived from this. Directions were chosen randomly so as to just complete the loop. You're getting initially when we chose the direction, I have chosen, see, from the positive terminal of the cell, the current will come out. This is at least fixed. Okay, this is fixed. Follow this. So from I3 one current was coming, from I1 one current was coming. These two things were fixed. Now rest of the distributions you have to do stepwise, taking the variables, eliminating the rest of the variables. Got it?
yes.
Aisha, were you asking something in between? No? Aisha? You're not audible. Please type if you're asking something. So yeah, from here we went from A to B, so negative 4I2. From B to C, same direction of current, I2 plus I3 into 2 with a negative sign. Now let's go from from C to A, the last side of the loop, completing it. Okay, Aisha. Look, we are going from C to A. Okay, this is resistance is 1, current is I1. So the resistance into current will be just I1 only. This will be I1 only. What about the signs? We are still moving along the current. Current also moved clockwise in this. We also moved clockwise, so it will be negative again. Now comes the battery. What did we study? From the negative terminal to the positive terminal, if you're moving, it is plus E. Plus E. Negative to positive if we are moving. This is our direction. Here we studied no minus IR if along, here opposite. So we are moving from negative to positive. So we'll put a 10 volt, entire voltage is written is equal to 0. Tell me, is there any issue with this or anything you want me to repeat from this part? Yes.
I am not able to understand.
Which part, Ubedullah? Tell me which part you are not
Last
able to.
one. This plus 10V is equal to 0.
Plus 10B? Okay. Ubedullah, tell me what was the direction we have chosen, clockwise or anti-clockwise?
Clockwise.
Clockwise. So if this branch AC, what will be clockwise? Will it be C to A or A to C?
C to A.
C to A. This is how clockwise go. This is not a perfect circle. This is just a triangle. But go clockwise. Clockwise you can go. So you are going C to A. So when you're going from C to A, which terminal is coming first? The smaller one or the greater one?
Smaller one.
Smaller one. So smaller one is the negative one, lower voltage. Whenever you go from the smaller voltage, low voltage to a higher voltage, EMF will be plus. The sign will be plus. Now, why was I writing this 4 into I2 like this? Because this was voltage 4 into I2. But 10 volt is already a written EMF. It's a cell, it's not a resistor. It already has a prescribed voltage. So what did I do? I just wrote the voltage as it is because I don't have to do I into R right now. The resistors are not given, it's just a cell. But for the direction, if you encounter the shorter one first and then the longer terminal, means lower to higher, you put a positive sign. If I had taken this direction opposite, the entire answer would have been opposite. These would be plus, this would be minus. But eventually you'll get the same final result because what was positive will be negative and this will also be negative. Now, did you get why this is my plus 10 volt Ubaidullah?
Yes, ma'am.
Okay. Is it clear to everyone now? Others? Ali, what about you? Marwa, you getting? Okay. So, see this. If you solve further, this will be minus I1 minus 6 I2 minus, minus 6 I2 plus I3 is there and 2. So plus 2 minus 2 I3 and then this 10 volt is only left. Plus 10 will be 0. If you solve this equation further, you will get this. Now this cannot be solved further right now. So let's say this is our equation 1. Let's come to another loop. Now see, pay attention here class. Let's say in this loop, now I'm reversing my direction. I'm taking anti-clockwise. Anti-clockwise will be C, A, D, C, like this, right? This is anti-clockwise, opposite direction. So my loop here is C, A, D, C. So I've taken in loop C, A, D, C, this loop. Now see, you are moving from C to A. Okay, C, A, D, C. Look class. Okay, we are moving anti-clockwise. Here also the direction is anti-clockwise like this. Anti-clockwise would be C to A, right? C to A. Current is I1, resistance is 1, so I1 only, and we are moving along the direction of current. So this branch is just similar to what we discussed. When it was clockwise here, this was like this. In anti-clockwise, this is also like this. So here we'll get the same thing. Minus I1 and plus 10, it's the same from here. This, do you agree, all of you? Minus I1 plus 10? Ubaidullah,
I'm not able to listen.
did you understand this 10 and minus I1?
The last equation I'm not able to listen. Minus
This
I1
one.
minus 6. Yes.
Why are you not able to understand this one? Minus I1 minus
Last
I1.
one is total voltage, right? Plus 10 is total, right?
This is the total voltage equation. Okay, Ubaidullah, which we have used, which we have written using the Kirchoff's law. Okay, I have just simplified this. Minus I1 minus I1. Minus 4I2 minus 2I2 minus 6I2 minus 2I3 plus 10. This is just mathematics. Here I have not used any physics in this equation. This equation is clear. I have just written this equation in a simpler manner. Got it?
Yes.
Okay. See, I'll write this again. Look, I'm doing it stepwise. Please pay attention, all of you. Please pay attention here. C to A because I am going anti-clockwise. Anti-clockwise for this branch CA will not be AC, it will be CA. So when I am moving along CA, current is also moving along CA. So we are moving in the same direction. Same direction means along the direction of current, it's negative. What's the voltage? I1 into 1. I1 into 1 is I1. This is what I get. Then I move further. I see the shorter terminal first, then the longer. What did we study? Lower to higher, so plus EMF. So plus 10 I have written. Now coming to here, this is the next branch. Again, we are coming downhill. This is also moving towards D. We are moving in the same direction of current. Current is also going from A to D. We are also moving from A to D. So we'll put a negative sign. What is the voltage here? Current is I1 minus I2. Resistance is 4. Voltage will be I into R. That is 4 into I1 minus I2. Then we are moving from D to C, right? That's how we are moving anti-clockwise. So finally we are moving from D to C. Now D to C, current is coming from C to D, while we are moving from D to C. This is the opposite direction. So here we'll put a plus sign. That's what we have studied. Before this, I think everywhere we were moving along the direction of current. This is the first time here we are getting the opposite direction. So it will be plus. What's the current? I2 plus I3 minus I1. What's the resistance? 2. So this will be 2 I2 plus I3 minus I1. We have written and we are back. We have completed the loop. All the voltages are written. This means this is equal to 0 in this loop. Now I am just going to simplify this equation only in terms of I1, I2 and I3. This will be minus 7I1, 2, 4, 6, 7. 10 volt as it is. No change in 10 volt. Plus minus 4I2 and we have plus I2 and 2I3 from there. So it will be this is minus, this is 10, this is plus 2, this is minus 4, so plus 6. 6I2 plus I3 is equal to 0. Oh, this will be 2I3 is equal to 0. So this equation becomes the second equation. Now tell me, is this equation clear to all of you? Anything in this? Because this is the first example, you can have doubts. Is that clear? Others?
Ma'am,
Yeah, say
to that less than, can we put it anyway?
what?
Can we solve that plus 10 later? Like
Plus
after first doing this current voltage.
plus 10 later means where will you put it then? Means you will not write it.
First minus I1 minus 4 I1 minus I2. At last we can write it like that.
Means 10 shifted on this side. RHS.
Yes, sir. Because it is total voltage, I think.
So you have to write the minus 10 because from here when it will go, it will be minus 10. Make this equation first. Then you can solve it in any way. That is then simple maths. You can, if you are getting two equations, this is a question from NCERT because 3 equations will be made, which you will solve later. But in many questions that are given in the exam, the 2 equations are formed, which can be solved in any method, substitution method, any method you can solve these equations. So then you can shift, then equate both of it. That you can do, Bedullah. There is no issue. First, write down this. Once this is written, then you can shift anything here and there. Here also I've just added the terms. And when you shift this on the opposite side, that will be minus 10. Okay?
So,
Okay. Last loop, because 3 equations are here, so we need the third one. Last one is quite easy. This is, so I took anti-clockwise. Let's check clockwise again. Now this is which loop? B, D, C, B. Write the initial letter again. B, D, C, B. So in loop B, D, C, B. We have chosen a direction as clockwise. Okay, now look class. If I am moving clockwise, this is like this only. I hope it is visible. Like this. Now look, when I'm coming here, the positive terminal is coming first. I'm getting the higher value of voltage first, and then the lower value. It's opposite to what we've studied earlier. So what did we discuss? Positive terminal first, then negative. So this will be minus 5. Let's move to the other branch. B to D done. Now D to C. Current is coming from C to D. We are moving from D to C, right? To complete the clockwise direction. It will be positive. Resistance is 2. Current is this. It will be plus 2 into I2 plus I3 minus I1. ठीक है, plus I2 plus I3 minus I1. Then how are we going? Clockwise. Again, we will go up only to complete the loop. Current is coming from B to C. We are moving from C to B. So this will be uphill for us. Current is coming downwards. So resistance is 2, current is I2, I3. This will again be positive because opposite direction of current. Resistance into current I2 plus I3 is 0. Tell me, class. Is this clear? Now see, you can simplify in any manner you wish to. Okay. 4I1 is here. Four I1 and minus 5. Like this 5 is coming. So you can shift it any side, okay? You can shift it on the opposite side, so it will become positive. Then you can multiply this equation with 2. That will give you 10. Or you can multiply it with minus 2. That will give you minus 10. Then you can equate both these equations. That won't affect your answer. Okay, like this. Now you have 3 equations, 3 variables that you can solve later, because that is your mathematical part. Right now, application of Kirchoff's law is important. After this, we'll see a simpler circuit, a simple circuit. This will be solved very easily. But tell me, class, now it's clear. The last part is clear, last loop. Any doubt in this? BCD, BDCB?
That
Yeah, Vedula say.
BDCB, it is like just a straight line. It is
No,
not something close.
that isn't close. From where is it open? See, why do
It
you
is
want to
like
go
a
with
line.
the shapes of the wire? Why do you get affected by the shapes? If the same thing, I draw it like this. 5 volt. Okay. Here I am having 2 ohm and 2 ohm. Okay. From this wire went off. Now this looks like a closed loop. But when the same thing, instead of this bent wire, this is how the wire is put. Isn't it the closed loop? It's still, don't go by the shape. Go by the definition and the terms. That's what I was saying. This is a tough question of NCRT only. So the shape is more confusing. That's why this is the question that I have picked, not from your NCRT. You'll find it easier where I'll ask you all to solve. This is a little difficult one because of the shape. Like here it becomes difficult to identify it's a parallel combination. Here it's difficult to identify it's a closed loop. But see, class, these kinds of questions come in the exam. So you shouldn't be following the shape. This is looking like parallel, this is looking like series, this is looking like a closed loop. What's the definition of a closed loop? When we have a closed loop, there shouldn't be any opening in the wire where the current is not flowing. It's not violating that. Look, the wire is completely closed. If I just make it, if I just extend it like this, and I extend it like this, means I just bend the wire like this. Now it's a closed loop. So it's the same thing. Are you getting it?
Yes, ma'am. How are we naming it as BDCB?
Oh, in this question it was already named, but okay, this loop,
Yes, ma'am.
go with the branch. This is one single wire where a cell is placed. This is one wire, isn't it?
Yes.
So this is BD. Like this could have been written like this. If possible, this could have been written like this. This is B point, this is D point. And let's say this is the C point. Here between B and C, the 2 ohm is connected. Here between this B and C, 2 ohm is connected. From here the wire is coming. Then how would you have named it? BDCB? It's the same thing.
This one clear.
Look at the wire and write. Okay, class, please write this. And if still you have any doubts, you can ask. Solving of the equations, please do that later. Write it. And keep on texting me done so that it gives me an idea.
Ma'am, can you scroll up? Yeah.
No, 1 second. Yeah, okay.
Ma'am,
Yes, Ubedullah.
we find voltage at resistance only, right?
What?
We find voltage at resistance only, right?
Yeah, voltage. See, once you have the current, then individual voltages, anything can be calculated because resistances are already given. Then rest of the things can be calculated. Like in
Like
some
in last
questions.
group,
Yeah.
there is only two resistors.
Two resistors are there. Yes. Here, na? Hmm.
Yes.
So you'll get the values of current here. I3 will come. Why didn't we take I3? Oh, Aisha, because see, I3 is going across this branch only. There is no single I3 present. Here I3 was coming, we've included it. Here I3 was coming, we've included it. Here in this branch, there is no resistor. Our purpose is not to include the current. Our purpose is to write the voltages. Here 5 volt directly is given. Here resistors were given, voltages were absent. So that's why we had to apply Ohm's law in order to get the voltage here. 2 into I2 plus I3, 2 into and all like this wherever we did for resistors. Look, I1 was here also, but we never wrote I1 into 10 or something because I1 was included here. If this 1 ohm wasn't there here also, we wouldn't have included I1. So I3 wasn't included because there is no resistor. If I add a resistor here, that would allow the current product with the voltage to give a resistance to us. A direct voltage is given, so we don't require it. Okay?
Ma'am,
Yeah, Ubedullah, say.
in loop ABCA, we wrote minus A1 also.
Where?
ABCA.
Where we have written minus I1? Oh, that
Yes.
was 1 into I1, na? So 1 I have just not written. 1 into I1 is I1 only.
So why are we not doing in DDCB?
This one, I3.
Yes.
See, Obedullah, here the voltage is 5 volt. Directly voltage of the cell is given. So there wasn't any need to write I3. Here, in the rest of the resistors, we are writing V is equal to IR. Here the voltage is directly present. No need to apply Ohm's law. Here the resistor is there. How to know the voltage of it? So you multiply 1 into I1. Like I have written here 4 into I2. I have written here
Yes.
2 into this. This is also 1 into this. Since 1 into I1 is I1, I have not included the individual current. Since 1 into I1 is I1, so that's why we are getting minus I1. That's not just the current written, it's the voltage only. But here the voltage will be equal to current because resistance is 1. That's why. Okay. In
Yes.
every case, you see, we have written the resistance into current. Here also minus I1 I have written because this is the same thing. You can write it as minus 1 into this. But I get confused when 1 into like this is written, so I omit it. Here it becomes easier for me to identify. So that's why I've written it like this. Okay.
So we only find out resistors only.
We only
Find out resistors only.
Yeah, see, you are writing the net voltage. So for the cells, EMF is already mentioned, but resistors, where resistors are present, how do you get the voltage there? So using Ohm's law. So with resistors only apply this. See, that's what now you will get the rules that we have written earlier. See, when we are moving along the direction of for cells and resistor, there are two devices here. Cells and resistors separate. So if you have cells present, the rule is just write the voltage as it is because voltage is there. For the signs go by this minus 2 plus or plus 2 minus. For resistors, you have to apply I into R. That is the Ohm's law. If you're moving along, write negative. If you're moving oppositely, so write positive. So for resistors, only use I into R. Why to write I into R here where you already know the EMF? Got it?
Yes, ma'am.
Okay. Have all of you written it till here or still writing?
Done.
And the rest, apart from, okay, Aisha has written, Ali has written, Marwa has written, Ubaidullah, writing,
Finished.
finished? Okay. Just one last question for today. Now, see, this is a little easier for you to understand because here in this next question, two loops are there, small circuit is there, you will get the values very easily. You don't need a different circuit to be present here. Now, look, class, pay attention. Randomly, I'm taking current. And see, you can take any direction of current. Like, see, if a battery is there, if suppose you have taken this direction, then keep it as it is. If the net direction is matching with it, keep it as it is. So, but I prefer to take the current out from the positive terminal. That gives it a proper look. Now, see, I am writing the rest of the current distribution I'm doing. So, see, randomly I'm starting with the current distribution here. Okay, look, this is one cell. Let's say from this some amount of I1 current has come. So if this branch has I1, if this side, it means this also has I1 in this direction. This is very easy because two loops are there and these are not junctions. These are just wires bent. This is the same wire. This will also have I1 flowing. Got it? This is the same wire. It is just bent. That's why I'm saying this question is easier. You've got this I1 part.
Yes, ma'am.
Okay. Now from here, let's say 5 volt is generating some I2. So this will be the direction of current I2 throughout the whole wire. One wire is left, I2 coming from here, I1 coming from here. If I want, I can write the current as I3. I3 current flowing here, but why to write I3 when I1 plus I2 can be written? Try to write the least number of variables so you get the least number of equations. So I2 is coming from this side, I1 is coming from this side, they'll be added and I'll get I1 plus I2 in this branch. Look, I1 gone here, I2 gone here, again coming I1 plus I2. Is this distribution fine?
Yes, ma'am.
This you must have understood? Okay. Let's go in any direction. Let's go clockwise here and we'll go anti-clockwise here. Okay. So let's move. Okay, I haven't named anything. Let's say this is P, this is Q, this is R, this is S. Okay, because there wasn't any name given. Now in loop P, Q, R, P. Okay. In loop P, Q, R, P. So we are moving like this. Clockwise I took. So clockwise is this only. Okay. So from P to Q. Ubaidullah, can you tell me from here P to Q, what should I write for this branch? Only voltage is there because only cell is there, no resistor. And we are going
Voltage
from
plus 5.
plus 5
Yes,
because we are going from positive to negative or negative to positive.
negative 2%.
Are we going from negative to positive? Don't
No,
see the
positive
direction
to
of
negative.
current. So that is
Plus 5. Minus 5.
see, remember this one. Higher to lower. From remember it like this. From a higher value, you are going down to a lower value. So negative. From a lower to higher, so positive. So see, here we are going from P to Q. Don't see the direction of current for this. That's not needed. P to Q, positive terminal to negative. Higher to lower, minus 5. Okay. Now, Aisha, you tell me. P to Q I have written. Now from Q to R. One resistor
Ma'am,
is there. Yeah, Ubaidullah, say.
in terms of QP, it is going from negative to positive.
Yes, in terms of QP. But we won't see that. We are following our direction. For cells, don't see the direction of current. See your direction. Just for resistors, check the direction of current. When cells, much is not needed. Just see the value as it is, put the value. For positive, negative, see which direction you are moving to. Okay, Ubaidullah?
Yes.
Got it? Okay. Aisha, can you try this branch from Q to R? Will it be positive or negative? We are moving from Q to R. First tell me.
Negative, because direction,
Negative. Why negative?
direction is going
Direction is where?
negative to positive.
Negative to positive.
No. It's going opposite.
So for opposite, what do we write? Plus or minus?
Minus.
Check the notes. Along and opposite.
Negative. No, positive.
Plus. Okay. Because we are moving like this. So now current is I2, resistance is 200. So it will be 200 I2. Coming to here, the last branch. Marwa, can you tell me? We are going like this. We went from P to Q, Q to R, R to P. Positive or negative?
It's positive.
Yes, Marwa?
It's negative.
You're not audible. Please type. See, we are moving from R to P. We are going like this. We went like this. Now we are coming like this. Will it be positive or negative? Check it through. Are we moving along the current or opposite to current? Check it like this. Yes, Marwa. What is it? Positive, negative?
Negative,
Why negative?
because it's moving from higher to lower.
We are moving from R to P. Is it along the same, where the current is moving from P to R? We are moving from R to P. Are we moving in the same direction or opposite?
Opposite direction.
So for opposite, we write?
Negative.
No,
Positive.
positive. We write plus. So this will be plus 20 I1 plus I2. See, current into resistance. This is equal to 0. See, along the current, negative. Opposite to current, positive. Don't remember it, it's opposite, so it will be negative. This is the rule. This rule is fixed. Here you are independent to write. First loop is clear to all?
Yes.
Okay. Let's come to the second loop where I've already written that we are moving anti-clockwise. So this is in loop. It is, we are moving anti-clockwise now. So RPSR. This is how we are moving. RPSR. By the way, the naming of the loop doesn't affect. It can be written clockwise also, but this helps to remember RPSR. This is how we have to move. Ali, you are left. Complete this. From R to P, we are moving like this. We are moving from R to P. Positive or negative?
Positive.
Negative.
Positive.
Positive. Yes, this will be positive. This is in the opposite direction. So 20 I1 plus I2. Ali, tell it for the cell. We are moving from P to S in this branch. 4 volt is there. This cell is there. Positive or negative? We are moving from P to S.
Negative.
What, Ali?
Negative.
Negative. Yes, because you are moving higher to lower. Positive to negative, higher to lower. So it will be negative 4. Ali, tell it for this one. We are moving towards S. Positive or negative?
Positive.
Positive. Did you say positive, Ali?
Yes, ma'am. Positive.
Yeah. Because current is going towards P. We are moving towards S. Opposite, so positive. Plus 2 into I1. This can be written as. This is 2 into 2I1. And finally this. Ali, complete this also. What should I write? Tell the complete part. What should be written here?
Positive 60I.
Yes, very good. plus 60 I1 equal to 0. So these equations can be simplified by you, and this one is very easy to solve. Finally, you will get just an equation with I1, I2, and here also I1, I2. Two equations will be solved very easily also. Tell me, class, is this question clear?
Yes,
Uh,
madam.
Ma'am,
Yeah.
but in previous question we were doing different way for cells.
No? Did we? How? See,
Ma'am,
we were moving here from positive to negative. Look. Here also, in this, we were moving from positive to negative. It should be minus.
for
As it is
ABCA we did
minus.
plus 10.
In which one?
ABCA we did plus 10, but it was from higher to lower.
No. Were we going from higher to lower? We were going from lower to higher. This is what I asked you. Remember?
In terms of CA, it is going from lower to higher.
In terms of
CA,
CA, how higher to lower? Move from C to A. Which do you see
yes,
first? Shorter terminal or longer one?
shorter one.
So lower to higher.
Yes,
You asked me the same thing before, Ubaidullah, where I explained you this part. This was written for you. We didn't
in question 2 also, if we see in this way, then we should write plus.
here with the same method, okay? Come here. Tell me. Two batteries are there, 4 and 5. We moved from
So,
positive to negative here. We didn't go.
so
See the direction of current. That's what I was saying. See your direction, what we have chosen here. Here we also moved from C to A. So negative to positive plus 10. Here we moved from B to D. So positive to negative minus 5. Here we are
so we
moving
are
from
seeing our direction.
our direction. Yes, I told you. Not the current. Current just see for resistor. For voltage, just see
Okay.
from where are you going. Positive to negative, so minus 5. Here we went again positive to negative, so minus 4. It's even in both of them. Okay.
Yes, I was confused with direction of current.
Okay, no, not the direction of current. Practice these two. I'll share the assignment and do the assignments class so that we can have a discussion in the next class. Marwa, you are also now not submitting the assignments. Now I think your vacations must have started, all of you. Please share your assignments with the steps. Ali and Marwa especially. And Aisha and Ubaidullah, you're not even giving the answers. Please share your assignments. Class, take the screenshots and you can leave, complete it later because time is already up. 2 hours class we had. Please take the screenshot and you can leave now. Okay. Just one Wheatstone bridge derivation is there. I'll do it in the next class. Okay. Thank you.
Ma'am, we took resistors
Ma'am?
direction.
Yes. Say. Aisha, you say first. What were you saying?
Which direction do we take for this? Like not current, right? Then
We take the direction for current. Yes, the resistance part.
I was taking the direction of current, but it's wrong, right? So what should we take?
You were taking the direction of current where? In which part exactly, Aisha?
I said 200 minus because the direction is going
Yes.
opposite.
Okay, you thought it because of the direction of current. See, नहीं. देखो, cell के लिए कैसे होगा? For cell, see when you are moving your direction, these arrows direction which you have taken, take it for cell. Okay, if you see positive first, negative. If negative, shorter one is coming first, smaller one, then positive. For the cell, that's enough. But for resistors, it is along or opposite. Yeah,
What did you say? Can you repeat?
I'm saying for the cells, see your direction where you are moving. You are moving means this one, the red ones, the arrows that we take. Okay, so here what did we take? We have taken clockwise. So we are moving from P to Q. So don't see the direction of current. For cells, take your direction. When you are moving, if you see the higher terminal first, voltage will be negative. And if you see the lower terminal first, voltage will be positive. In none of the cases here, we saw the shorter one first. So it was negative in both of the cases. This is how we go about the cells. Cells part is clear.
Yes, ma'am.
For resistors, we have to check the direction of current that we took, because we have to see opposite or along. For that, we match it with our direction. Suppose I have taken here clockwise. I am going from Q to R, but current is going from R to Q. This is opposite, so positive. If I was going along this, suppose I took anti-clockwise here, R to Q, this would be along, so negative. Now got it?
Yes, ma'am. Thank you,
Okay.
ma'am.
Yeah, Ubaidullah, you were asking something?
So for resistance, we have to see current direction only.
Yes,
Like,
only
say,
current direction. Your direction and current direction, you have to match that, whether it's opposite or same. If it's same along the direction, same will be negative, opposite will be positive.
for cell opposite, we have to see our direction.
Yes, for cell, you just see your direction. You're not concerned with the current because you directly have the voltage. For resistors, we had to involve current. So that's why the rule is opposite. And this is a stated rule. Okay, this is already a stated rule. So we cannot change the rules. But you are independent to choose the currents and all. Apply KCL according to you, but KVL you are bounded. For cell, just see your direction. If you see shorter terminal first, positive. If you see the longer terminal first, then negative. Longer to shorter, higher to lower, negative. Lower to higher, like the 10 volt. I wrote plus 10 because we encountered smaller one first. Sell your direction. For resistors, the current direction. Match it with your direction. Okay?
Yes. In exam, will it be given to us that we have to use Kirchoff's law for solving?
Yeah, the Kirchoff's law come very less, but there are usually they are in the options. So it will tell you use Kirchoff's law. That's what I was saying. It's a very lengthy method. Advantage is that in any kind of circuit, you will get the values because you are dividing current. That's the advantage. But disadvantage is that it's actually very, very lengthy. Even I do not prefer to solve it till the end in the class. I just write the equations and leave because it is lengthy. So in the exam, yeah, many questions have come in your board exams to write the law, Kirchhoff's KCL and KVL. Do that. That is the easier one. And if you see such kinds of questions like this, where you see, okay, two loops will be there, two equations can be created, then go for it. You will get a good complete 5 mark for it. It comes in the longer questions. But if you are confused, a complex loop is there, don't go for it if it's optional. If it can be
Yes.
eliminated, try to save the time.
Yeah.
Okay?
Yes.
Longer, no, Aisha, I'll just make it a little clear for you. Look, Aisha, I'm writing it here. See, this is positive, longer one is positive, shorter one is negative. If you see positive first means the longer one. It means you are going from longer to shorter, higher to lower, plus to minus. That is they taken as negative. If minus, that is the first